I think this should shut down from being locked too long. So I'm just going to leave it.
Okay. Hopefully we're back online for the people who are.
Is it green? Alright, on it is?
Yes. Okay. Let's go back to where we were. Okay, so this is where we were. So this, as Tom very astutely said, we have a problem here, and the problem is to do with lifetimes. So let's imagine we're taking the cat branch. What we're going to do is, in between these pair of curly braces, we're going to create a cat, and as soon as we leave this block, that cat object is going to be destroyed. Which is a problem, because we're returning a reference to this object that is just about to be destroyed. As soon as we leave the function, any local variables, as soon as we leave this block, in fact, any local variables get destroyed. And so we're returning what's called a dangling reference. And as I said, very unfortunately, this code probably will compile. It will give you a warning, it should give you a warning, but in an ideal world, this would be an error. The compiler would prevent you from doing this. Okay, so this isn't going to work either. We no longer get slicing, but now we've got lifetime problems. So let's have a look at a slightly better solution. We're going to use something new here. Okay, now our getPreferredAnimal function returns a pointer, returns an animal pointer. So once again, we ask the user for their preference. If they prefer cats, we return a new cat. We have this new keyword. The new keyword is new. Otherwise, we return a new dog. So rather than returning a reference, now we're returning a pointer. When we call this function, we capture the pointer that is returned from it. We call our do something by dereferencing the pointer. When we dereference the pointer, we obtain a reference to it. So we can call do something by calling *A. And then when we're done, we delete the animal that we were given. Okay, so we've introduced these two new keywords now, new and delete. So what's happening here is that when we call new cat, that allocates a cat object on the heap, on the free store, in your main memory, in RAM. And it returns, well, new returns a pointer to the cat. Cat publicly inherits from animal. So a pointer to a cat can be converted to a pointer to an animal. And then later, we call delete on that pointer that we were given. And that will, hopefully, if we've got things right, delete the object that we allocated with new. So let's have a quick overview of new. So as I say, it creates an instance of a type on the heap, on the free store, as it's called. Right, so we look at the syntax. We can use it for fundamental types as well, like ints. It's usually used for object types, though, for class types. So this says pointer, PTR, which is of type pointer to int. So we declare this new variable and we set it equal to this new int, which we've initialized with value 3. Okay, so new returns you a pointer to the object that it has just created. So new will run the constructor for your class type. Int doesn't have a constructor, but the syntax is the same. If we instead called something like a standard string, that would call the standard string constructor. It would allocate memory and then construct the object in that memory that it's just allocated. and then it returns you a pointer to that memory. Returns you the memory address, returns the address of this object that it's just created. Later on, when we're finished with it, we have to use the delete keyword to get rid of the object again. What delete will do is call the destructor of the object and then free the memory that it allocated. And delete just looks like this. You just pass it the pointer value that new gave you. So new creates things, delete destroys things. But here's the kicker. Every use of new must be paired with a delete. Whenever we create an object with new, we must have a corresponding delete that is called exactly once. No matter what our code path is, we must call delete exactly once.
Just to expand though, if anyone goes Googling and looks up new, there's something called placement new.
Oh.
And you don't delete that, but otherwise you do carry it.
Yeah. There's also array new and yeah. This is the simplest form of new, and the reason I'm introducing this is because in a few minutes I'm going to tell you never to use it. So, whenever we create an object with new, we must have a corresponding delete that is called exactly once, no matter what code path we go through. So if we don't call delete, the object is never freed. We have a memory leak. We've allocated some memory, and that memory is never freed. Right, that's bad. Sorry?
You can call more than one slave.
Yes. If you call delete more than once with the same pointer, you're going to get a double delete. And that will probably crash your program. Probably. It's not guaranteed to. Might not.
Didn't we set the actual pointer to a null pointer?
No.
Okay, possible.
So if you're lucky, this will crash your program. If you're unlucky, it will appear to work, and you've probably got a security bug in your program, and oh, it's nightmares. Right. Ensuring that delete is called exactly once, exactly when we finished using the object, exactly at the right time. So we're not hanging on to it for too long and wasting memory. And we're not calling delete twice. And but we are calling it at least once. And we do this no matter how we copy our objects or what code path we go through or what exceptions are thrown. Exceptions are really make this difficult. Right? This is what we had to do in C++ 98, and it's really, really hard. This is really hard to do properly. Have we got another problem with this tree? So, how can we make this? How can we make our lives better? How do we ensure that every new is paired with a delete, and this delete is called once? The solution that almost every other language has to this is to have a separate process called a garbage collector that sits around and watches for when you've finished with things and deletes it then. Right? So Java, C#, Python, sort of, Go, these all use garbage collection. D is another one. There are lots of them, lots and lots of them, all the Lisps. JavaScript, they use garbage collection. In C++, we have a different solution. Which I'm going to say better because, hey, this is a C++ course. We use destructors. We use this RAII approach that I've talked about lots of times. Because in C++, the language guarantees that the destructor will be run on an object we've declared locally. The destructor will be run when we leave that scope, no matter how we leave it. Right? Whether it's by return, whether it's for a void function, whether it's by falling off the end of the function, whether it's by an exception being thrown. However we leave that scope, the destructor will be run and there's nothing you can do to stop it. It will happen. So if we could arrange things, if we could write a class that calls delete in the destructor, that would really solve this problem of knowing the right point to call delete. And people realised this quite some time ago. And they started to write these classes that managed dynamic allocations like this. And they call them smart pointers. So a pointer holds the memory address of some object. A smart pointer holds the memory address and smartly handles things like copying and destruction. Lifetime management. So let's have a little example of what one of these classes might look like. I'm going to call it BadAnimalPointer. You'll see why it's bad in a minute. But this is a smart pointer that wraps an allocated animal. An allocated animal pointer. So here's the animal pointer that it's wrapping. Set it to null pointer by default. So we'll open the public section of our class. Remember, I've used the class keyword to declare this. So by default, things are private. Okay, what does this line do? Just a little bit of revision.
It's a default constructor.
It's the default constructor, absolutely.
Explicitly default.
It's an explicitly defaulted default constructor. And if I put the keyword explicit in front of it, it would be an explicitly defaulted default constructor.
Well, it wouldn't mean anything.
Actually, it does, but anyway. Okay. So what does this line do? What does this line declare?
It's a copy constructor.
A copy constructor. Well, it's not quite a copy constructor. A copy constructor would take another instance of BadAnimalPointer by reference in there. This doesn't do that. This is a constructor which takes an animal, a pointer to an animal. And then in the member initializer list, I've set our member called PTR equal to this pointer we've been given called A. Right. No other initialization I need to do, so the body of the constructor is empty. Now, here's the key line. This is the destructor for our BadAnimalPointer. So when one of these objects is destroyed, it's going to call delete on our PTR object. And you say, well, what happened? Well, you might say, if you're paying attention, if I default construct one of these things, then PTR is going to be equal to null pointer. What happens when I call delete null pointer? And the answer is that's fine. That's allowed by the language. Delete null pointer does nothing. It's perfectly safe. But if we use a second constructor and we set PTR equal to something, equal to a value, then we're going to delete, or we're going to attempt to delete the object at that memory address. And then, because this is a smart pointer, we want to add lots of operator overloads to make it behave like a real language pointer, like a raw pointer. So we overload the dereference operator, operator star, which just dereferences our contained pointer, and lots of others, operator arrow, operator bool, I forget the rest. But there are quite a few that we have to do to make it work like a real pointer.
Why is it important to put const after the parentheses?
In here,
Yeah, like what was it that served? I mean,
It's actually wrong. It should be constant.
no, it's not.
Const instance. Constant because it's behave like a constant point. Yeah. No, you have a const. No, because you have a const t star. The pointer itself is not const. The object you want is const. So the object you want from a const accessible member version of BadAnimalPointer would be a const animal.
I'm pretty sure this is right. And look up unique pointer and CPP reference and tell me.
Because you need two of them. You need a non-constant.
Just-
Alright.
I'm pretty sure this is right. Okay, so what const does is it means we're allowed to... Oh, sorry.
So, but if it's a constant member function, should you not return a constant animal?
That was what Ollie just
That's what
said.
I'm saying, 'cause it would be-
Should I return a const animal reference?
Well, no, it'll work. I'm not saying
it mean from a point of view?
Is it semantically correct?
Yeah, I'm wondering.
And I'm saying this is semantically correct because it's what we'd get if we dereferenced a const pointer rather than a pointer to const. That's my argument. Now I'm getting nervous because I don't like being corrected like this. That says no.
Adding an old money reference on T.
Yeah, but it doesn't add const. So unique pointer. Sorry, right? Yeah. So this is the difference between a const pointer and a pointer to const, which is a rabbit hole I didn't really want to go down, so perhaps we'll avoid it. The point is to remember that a pointer is a value object, so we can have a const pointer. That is a pointer whose value can't change after you've initialized it. So you create a const pointer and it points to this object and you can never change what that pointer points to.
But here you can't change the operator.
Okay, so this means we are allowed to call this operator on const instances of BadAnimalPointer. So if we wrote const BadAnimalPointer equals something, we could still dereference that. So, Ollie, in the body of this, because it's const, it behaves as if we'd written const there and not there.
There's a const pointer to a non-const object.
Yes. Right. Let's avoid going too deeply into that, or it's just going to get horribly confusing. The point wasn't to argue about whether this animal should be const or not. It was just to show you that if we're going to call this thing a pointer, if it's going to behave like a smart pointer, we need to override the operators so that it behaves like a smart pointer. And operator star is one of them. There are a few others. And the operators weren't even the key bit. The key bit is this line, the destructor. The destructor, when we leave the scope, will delete the pointer. Delete the contained pointer. So how do we use this? Well, this time our getPreferredAnimal is returning this animal pointer thing. And again, if the user prefers cats, well, what do we do now? Now we return a BadAnimalPointer. And we create this, we pass its constructor a new cat. So cat, new cat gives us a pointer to some memory allocation that contains a cat. If that memory allocation contains a cat, it certainly contains an animal, because an animal is a cat. So this calls the constructor that took an animal pointer. And then we return this object we've just created. If the user doesn't prefer cats, if they're normal and they prefer dogs, then we wrap we create a new dog and we wrap it in this smart pointer, this BadAnimalPointer, and we return that from the function. And then in main, we capture the returned smart pointer. And just like we did when we had a raw pointer, we dereference it and pass the result to do something. So this is roughly what we had before, except I've changed from using animal star, that is a raw pointer to an animal, to using this smart pointer, this bad smart pointer. We'll see why it's bad in a minute. I had to name it bad just in case anybody sees that slide in isolation and thinks, oh, that's how I write a smart pointer. Right, that's why I wrote it bad. That's why I called it bad. But here's the point. Here's why we're going through all these hoops. It's because we no longer need to write this line. We no longer need to manually delete A. Because the destructor of our BadAnimalPointer here is going to call delete for us. No matter how we leave the scope, so if do something through an exception, then we would, in the old case, we would actually never execute the delete line. That would be really bad. But here, it's done in the Destructor. That's guaranteed to run. So we're guaranteed to call delete.
So you can't really think about it moving the delete A from the main to class.
That's a really good way of thinking about it in a minute. It's not quite yet. You're thinking very much along the right lines. Just we haven't quite got all the infrastructure right yet. And I'll show you why about now. So yay. This is getting better, but we're not quite there yet. So here's a problem. What happens when we copy a bad animal pointer? So now I'm capturing this A, and then I'm creating a new copy of it called B. So what's going to happen when this code runs? Sorry? Magic. Well, something a bit worse than magic, unfortunately.
What happens when they both go out? So,
Yeah.
How many actual underlying objects are
Let's go back a step. What does this line do? When we copy a class object, we run the copy constructor. Okay. But our class, too far. We didn't write a copy constructor. None of these things are copy constructors. There's a default constructor, there's a constructor taking animal, and there's a destructor. There's no copy constructor there. So what happens if we don't write our own copy constructor? Sorry?
Sorry, what did you say?
If we haven't written any constructors, then it's automatically made.
Okay.
If not,
So we haven't written our own copy constructor. We haven't written our own move constructor either. So we're going to get a defaulted copy constructor. An implicit copy constructor, that's a better way of putting it. Okay, compiler generated copy constructor. And what does the compiler generated copy constructor do?
The elements of value.
Copies each of your member variables by value,
by their copy constructors?
using their copy constructors. So in this case, our only member variable is an animal pointer. Right? Said this many times. A pointer is just a memory address. Works more or less just like an int. It's just a value, just a number. Okay, so when we copy this, we're just copying that value. And that's fine. The copy constructor for this class is perfectly well defined. The problem is not with the copy constructor. Well, not with the compiler is doing exactly what we asked it to do. I just have to scroll through this to get there. So the copy constructor, that should say implicit. The implicit copy constructor for our bad animal pointer will just copy the pointer value. So now A and B both have this PTR member variable, and they both contain the same address. Okay? So what's going to happen when we reach this closing curly brace? When these variables we've got, A and B, go out of scope.
One gets deleted, and the object is gone, and the other tries to delete, and the object is already gone.
Again, you're on fire today, yeah. So absolutely. So what's going to happen is objects in C++ are destroyed in the reverse order they're created. So B's destructor is going to run first. It's going to call delete PTR. Well, we said PTR has got its value in its copy constructor, so it's going to delete this object we allocated. So that's fine, it's gone. This allocated object is now gone. Unfortunately, then A's destructor is going to run. And we haven't, A still contains a pointer to this same now deleted bit of memory. So when A's destructor runs, it calls delete PTR. And it's trying to delete something that has already been deleted. So when the second destructor runs, boom, the program will explode. We will crash. This is bad. This is really bad. So in C++ 98, the bad old days, what you had to do was whenever you had a class that contained a pointer to some other instance, you had to go out of your way, you had to write a copy constructor and a copy assignment operator, and you had to make sure that that did the right thing and then it handled exceptions properly, and it was an absolute nightmare. It was really hard to get right. It was a lot of boilerplate, and it's one of the big reasons really that Java took off in the 90s, because people were so sick of doing this in C++. They went, oh, this Java language is really nice, it's got a garbage collector that looks after all this stuff for me. And a big reason that people have come back to C++ after C++ 11 was because we got a better way of doing this. Right? And that required a new addition to the language. That new addition they call move semantics. So C++ 11 added this new fundamental operation, moving. So we've talked a lot about copying objects. When we copy something, we're creating a new instance that has the same value but is completely independent. Another way of saying it, when we copy construct an object, we create a new object, leaving the source unchanged. If you remember way back when I was talking about Word documents, I said, well, imagine, if we have a Word document, it's got the contents, that's the value of the object, and then we create a new document and we copy and paste the contents of one object, the contents of one window into the other. Right? That's what your copy constructor is doing. Right? Copying and pasting something doesn't change the source. But now we have this new idea of move constructing something, moving an object. And rather than copy and paste, this is more like cut and paste. Right? So when we move construct something, we're potentially at least changing the source object. We're stealing the contents of the source object and putting it directly into the target. They're talking about move construction. We have move assignment as well. Now, honestly, move semantics, if I was going to explain it fully, it would take at least one of these sessions by itself, probably longer. I'd have to talk to you about R value references, which means telling you what R values are, which means talking about PR values and X values and GL values. Getting a whole, a fundamental understanding of this stuff is pretty hard. However, we don't have to have this very, very deep level understanding in order to be able to use these things. What you really need to know is that moving is in some sense stealing the contents of another object. Modifying the source object. Creating a new object but modifying the source object. And there's this function standard move in the standard library. And when we use standard move, we are making a variable available for moving. So it's probably going to be a better example than I wrote there. I'll just so let's say we create an object A. Now we create an object B as a copy of A. So A and B are independent objects, but we haven't modified A. We've just created a new copy of it. If we instead say object C equals standard move A, so this should be all on one line, I just ran out of space. If we say C equals standard move, then what we're saying is create a new object C and steal the contents of A. We'll have another example. We've got this type movable. So we've got a function that takes some movable object M. And in main, we're creating an instance of movable. And then we're calling the function, and we're wrapping M in standard move. So we're saying, usually func takes its argument by value. So usually we'd pass a copy of whatever we call it with. Because we've wrapped it in standard move, we're not copying into it, we're moving into it.
Maybe another way to express this is that you know you have movable, right? So you have a type T, in this case movable. And then you know what a reference is, right? T and, movable and. So then we have, and this is slightly bastardizing the language, but it might make sense. We have what's called a movable reference, which is T and. So all stood move actually does is it just says that it just casts it to T and add. So when movable value constructs and whatever you pass it, because it's declared as T and it guts the contents of that object. In the same way that if you had func int I, so func takes an int by value, if you pass it some int you already declared, like say x equals 5, right? You pass x, it gets a copy of x, because x is copy. But we could also just, put the character 5 in there. We can pass it 5 directly. When we pass that 5 directly, you know what I mean, right? Just parentheses the number 5. Yeah. So that 5 is not an L value. It's not a variable. It's just an expression in the code. It's just the number 5. So therefore, the compiler can just put that straight in the value type that's declared as the parameter of the function. So just move is just saying that we're going to treat this as something that's in line and we can gut its contents. Carry on.
Okay, so what this is doing is it's moving the variable M into this function. So we're stealing the contents of M. So M is left in what's called a moved from state. And in general, the only thing we can do with a moved from object is to let it be destroyed or reinitialize it. Right? Generally speaking, cannot be used after it's moved from. So again, giving a full treatment on move semantics would take a lot more time than we have today.
When you say gut, is it because you're, when you say reference, is it because you're just pointing it to somewhere else? Like you're...
No, this movable reference that Ollie was talking about, that's how this moving stuff is implemented, right? In the language, they added this new kind of reference that allows this to happen. But you don't really have to know too much about what are called R-value references, movable references, in order to be able to just, I guess, grasp the idea of what moving does and how this standard move thing works. Yeah. What it'll do is it will move that object and leave this M in here. If there was further code down here, we wouldn't be able to use this M because we've just moved it. We've just moved from it. We've removed its internal contents.
If you use M, does standard move have no effect?
If I what, sorry?
If you use M afterwards,
Down here?
Yeah.
Yeah.
standard move.
That will probably be an error.
It's a standard with I thought standard with so the reference
No,
the reference can collapse it back into another value because it's
all right. Again, not wanting to get too deeply into exactly how this works, but if Moveable didn't have a move constructor, if it was an old type that only had copy operations, then standard move would have no effect, it would just copy it. Similarly, if Moveable was declared const, well, you can't change, in that case you wouldn't be able to change the source object, so you wouldn't be able to copy from it, so in that case move would in fact just do a copy. It would fall back to a copy. Right, so wherever a move, wherever you, what's a better way of putting it? We can fall back to a copy without changing the semantics of this. It would just be slightly less efficient.
So going back to what going back to your pointer example on the different board.
None of these are pointers. I'm not talking about pointers here. These are just.
Oh, I thought you were going back to solving the problem.
I will be talking about smart pointers in a second. This is just some object.
So you've moved A,
Yes.
but can you still use B and C?
I heard a whisper. Yes, absolutely you can. Right. So this is copy construction. So A and B are completely separate objects.
Yeah.
Right. And now we're creating a third object, which I don't have enough hands for over here. And to do that, we're stealing the contents of A. So A is no longer usable, but we've still got two objects that are usable, B and C.
But generally, the thing we can do with it, the only thing we can do with it is let it be destroyed.
Yes, the A object. So the thing we've moved from is A. So we can't use A anymore after this line, but we can use B and C.
You could move something into A.
Yeah, we could reinitialize A.
Yeah.
Let's say. But so we've got two objects that we can use. After this point, it's no longer in general safe to use A.
If you invent your own type, then moving from that type means whatever you decide it means, right? So maybe you decide that you can no longer copy from this object because it's been moved from. You can no longer use certain functions on this object or any functions on this object because it's been moved from. It's up to you. In the standard library, it just says that the object is definitely valid but unspecified state, which means you can stick stuff in it, you can reset it. Depending on what it is, you may be able to do certain things to it, but generally speaking, there's stuff, most stuff you can no longer do.
If you made func return m again, and you did m equals func down there, would that be like giving it that thing and getting it back?
That would actually be okay, yes. If func modified its argument in some way and returned by value again, then we could say m equals func. That would be reinitializing m. So then that would be okay. That would be a very functional programming way to do it, right? It'd be better just to let func take a reference to m, right? But it would be legal code. It would not necessarily be optimal, but it would be possible. So anyway, C++ 11, probably, arguably, the biggest change in the language was this addition of this new fundamental operation on objects called moving. And they did that for two reasons. Or rather, it solved two problems. Firstly, it let us do things more efficiently. If you know you're never going to use something again, you can move it somewhere else. Right? Which for things like vectors and strings, that's a more efficient operation than copying, because you don't have to do another allocation. Right, that solved one problem. The other problem it solved was this problem that I've just shown you, of having these resource-owning smart pointers that we can't copy, can't safely copy, because then they both think they own the same thing. So these move semantics let us write types that can't be copied. If we try and copy it, we'll get an error. They only have move operations. So if object here was a move-only type, if it had no copy operations, then when we tried to do this copy here, we get a compile error. We wouldn't be allowed. But this second one, this move operation, that would be okay. So in C++, by default, we use copy, and we have to use the standard move function in order to move things. Anybody's familiar with Rust, it also has notions of moving and copy, but it has the opposite defaults. Rust move things by default, and you have to explicitly ask it to copy things. But we can have these types, we can have these classes that cannot be copied, they can only be moved. And if we could apply these ideas to our animal pointer, to our animal smart pointer, we could solve the problem. Because the problem was when we copied an animal pointer, both of our objects thought they owned that allocation. But by using these move semantics, we can move the ownership, conceptually, move the ownership of this allocation from one object to the other. So, okay, what I could do now is I could go and show you an example of how you do this. I could show you how to write a move constructor and a move assignment operator. And perhaps if we had a bit more time, I would. But it would all be rather needless, because the standard library already provides exactly what we need. It has this object called standard unique pointer, which is, after vector, perhaps the most useful class in the whole of the standard library. Because what unique pointer is a smart pointer which is move only, that is, it cannot be copied, and which calls delete in its destructor. So let's have a look at what our code looks like if we use this smart pointer, this unique pointer. So unique pointer is what's called a class template. It's like generics in other languages. So we have to tell it what the type is that we want to contain. In this case, we want a unique pointer to an animal. So again, ask the user for their preference. If the user prefers cats, we return a unique pointer to an animal. And we call the unique pointer constructor, passing it a new cat. So this is like we had for our BadAnimalPointer, except now we're using this better standard class called unique pointer. If the user doesn't like cats, that line should be gone. Bad copy and paste on my part, sorry. Let's try that one again. Okay, this is rather a mouthful. So we have this magic function in the standard library. It's called makeUnique, and what that does is it makes a unique pointer for us, right? And you pass, in this case, the dog constructor and the cat constructor take no arguments, but if the constructors did take any arguments, you put them in the braces there. So this calls the default constructor of dog and allocates a new object in the heap and wraps it in a unique pointer. And it does that all on one nice smaller line. So makeUnique is great. makeUnique was actually added in C++ 14, but that's what we're using in this course. So now in main, we say unique pointer to an animal, okay, is initialized by this get preferred animal. And again, this is pretty long. We could just say auto A there, it'd be nicer. And then unique pointer is a smart pointer, so it can do all the things that a pointer can do. In particular, you can dereference it. So we call do something on start A, and that gives us the animal reference, so we can call this do something function. And at this point, at the closing brace, all our local variables get destroyed. Well, we've only got one, it's A. So A gets destroyed, so it calls the destructor of unique pointer. And what that will do, we'll call the animal destructor. We'll call delete with its internal pointer. That will call the animal destructor, and then return the memory we allocated to the operating system. Free the allocated memory.
Could have used auto down in main.
Yes, yeah, you could, yeah. I was just writing it out longhand just to show you what the type was, but normally, or at least I would use auto there, because it's a lot to type otherwise. Yeah. Yeah, I know. I'm racing. Yes. So, some guidelines for smart pointers. Smart pointers should always be used in preference to manual memory management. There is almost no reason ever to use new and delete in new code that you write today. If you look at old C++ 98 code, it is filled to the guts with new and delete. New code you write today, there is never, asterisk, a need to use new and delete. The asterisk here is that, well, actually, there are some old libraries, and in particular Qt, if you've heard of it. It's a very widely used library for doing user interfaces. Qt has its own funny memory management style, for which you still, unfortunately, need to use new. But for the most part, unless you're specifically using a library that requires it, for the most part, you should never use new and delete manually. You make unique to create things, and then use destructors to free things. So standard, I've talked about unique pointer. The standard library also has a second kind of smart pointer in it called shared pointer. Shared pointer is a reference counted thing, so it's if you use Swift or Python as well in some implementations, they use reference counting for memory management. Objective-C does it a lot as well. So shared pointer uses reference counting. And that can be useful for some things. It's also overhead in some cases. And in general, it's a better idea to use unique pointer. Use shared pointer only rarely, and only where you genuinely need shared ownership. For example, if you've got threads working on the same data and you don't know which one's going to get finished first, so you have to keep the object alive until the last thread is finished, that'd be a good use case for a shared pointer. But otherwise, a unique pointer should be the default that you reach for. And the last point is that in new code, whenever you see T star, that is, whenever you see a raw pointer, a language pointer, that should never be what we call owning. So you should never have to, because we're never using new and delete, we never have to call delete on a pointer. Right? This raw pointer never owns a resource. We might still have them in our code, but they don't own things. They just point to something. Okay. We're almost done. I've got 2 slides left. This has been an info barrage, but unfortunately we started late and we've got this fun thing to do, so I've had to race a little bit today. So it has been an info barrage, but we're almost done, people. We're nearly there. So here's the problem. Well, this bit itself is a problem. When we create a unique pointer to a base, it may be created with a pointer to an instance of a derived class. Right? So back in the slide before, you saw unique pointer angle brackets animal, and I created that with a new cat. And that's fine, as far as that goes. The trouble is, when the unique pointer's destructor calls delete, it only knows about the base class pointer. It doesn't know that this pointer really points to a cat. It only knows about the animal bits. So when delete runs the destructor, it's only going to run the animal destructor. It's not going to run the cat destructor. So how do we ensure the derived class's destructor gets called? Well, we have to use something called virtual destructors, which there's a slightly big hint on the top if you hadn't done that originally. These are slides I nicked from last week. So. We've already talked about this. C++11 smart pointers make memory management much easier. But we need a virtual destructor. So here we've got our animal, I called it animal iFace today, or last week. We called it animal so far today. So we've got this pure virtual member function, speak. And now we've declared, that was really bad. Come on, Tristan, you weren't awake when you wrote this. Come on. Sorry, let's try that again.
It's recorded.
No, it never happened. It was like this all along. So, we've got our animal. It's an abstract class. It's got this pure virtual method. And what we've declared is that our animal destructor is virtual. And what this means is that if we try to destroy a derived class via a base class pointer, everything will happen correctly. If all that sounds a bit weird, just remember this. If your class has any virtual functions at all, give it a virtual destructor. If you follow this advice, you will never go wrong. If your class has any virtual functions, it must have a virtual destructor. Now, if there were any watching on the stream, there are very, very pedantic C++ people who are going, yes, but my particular use case, I don't have to. If you follow this advice, you will never go wrong. This is really safe advice. And this includes pure interface classes. So like the logger and the fancy logger we saw before.
Especially those. You've got some members.
Yeah. In fact, especially those. So if you don't have any work to do in your base class destructor, then you can just use equals default. It's possible the language allows you to mark a virtual destructor as pure virtual, that is to put the equals naught at the end. Don't do it unless you really know what you're doing.
Or provide a definition as well.
So the most important here is really the top one. If your class has any virtual functions, give it a virtual destructor. Do that and you'll never go wrong.
Well, a key point to make is that when you declare something as pure virtual equals 0, it just means that you're saying you're not allowed to instantiate this object. That pure virtual member function can still have a definition, and derived class can also legally call that pure virtual function as long as you can get a definition. It's just that it prevents anyone from directly instantiating it. And if you do have a pure virtual destructor, you have to create a definition out of line. So you have a class, and then you have the definition of that pure virtual destructor, and it will work fine. If you don't, it just fails to link your compiler won't link.
So when on the third one down, the virtual structure may be defined with the default. Is that with the approximate sign on the front of
The tilde.
the tilde?
Yeah, that means
So
destructor.
but it's not the destructor's not defined with just the default.
So no, it is defined, but it means that anyone using it will basically generate it.
So you need tilde.
You always need tilde. That means
So
tilde
this
means
is how we
that-
declare a destructor. It's just by saying the tilde and then the name of the class.
But not having the
Virtual on the front.
virtual and the tilde on the front, and just have animal equals
That would be a constructor. That would be a default
There's no
constructor.
destructor in that constructor. You see what I mean?
Constructors and destructors are separate.
Right, okay.
Default and non-virtual. You could just use empty curly braces as well. You don't have to, if you don't want to write, you should write default, but you could alternatively just put 2 curly braces, open and close, and do the same thing.
I'm just getting there.
Actually, probably another point you haven't mentioned. When you're writing your implementations of your interfaces, if you put a destructor on your implementation, so the derived class of the interface, you can mark it as override as well. So you can require that the base has a local destructor and you have to bug there. So if you need a destructor, mark it as override, and it will fail to compile if the base is not actually virtual.
Do you know that actually bothers me because destructors don't override; they chain up.
It is literally an override.
Well, it's not.
But okay, I get you, they chain, but it's a good compile time change.
Yes. Yeah. Just the keyword bothers me. The keyword-ish. Anyway, eventually Slack will load and I will be able to get the URL that I need for you.
I mean, it's a short link, just tell it to you, later type it in.
So I got it now. Right. That was the end of our fun today. And you know, usually I give you some work to do. Usually I give you some work to do during the test, during the session. Today it was just one massive info burst, so sorry about that. Usually you get your hands on the keyboard a bit more. But today, because we've reached the end of the module, Ollie has prepared this little questionnaire. Let's call it questionnaire. I like the word questionnaire better.
It's a bit boring.
Sorry?
It's a scored questionnaire,
A scored questionnaire, yeah.
otherwise known as a test. Everyone got internet?
It's just doing an update.
CPP London Uni, and the password is not securing Wi-Fi.
Is that an L? Or even that
Slow
WL?
Wi-Fi.
That's bit.ly.
The real one is securing email. So it's
2Q.
Oh, yes, that's a good question. I don't know.
L.
I don't know.
Lowercase L.
These fonts
Let me
are
just
also-
change the fonts.
Just choose 2 options.
Put in Korean U, that's right. It's an L, it's a lowercase L.
Really?
Yeah. I'll paste it in CPP London Uni.
2Q.
on Slack.
2 capital Q, M, W, L, capital A, K. So if you have any problems accessing this, just put your hand up.
There you go, it's in
Oh.
Slack. You're on Slack. Then.
For the new guys, you are obviously excused.
I'll have a look, but it might.
I want to see how Chandler does.
Oh, I'm supposed to fill this in.
You don't have to. You don't have to be able to. Don't worry about the view. Don't have to do that. Also, a quick point for this test: for the questions that ask you to write your own code, it's fine if you want to do that in an IDE. So you can write your code in Wandbox or in C-Line or whatever you want, and then once you've got it working, paste it in to answer the test. But do not copy code that you need to analyse. So you can write your own stuff and put it in the answer, but don't. It would be cheating if you copy stuff out to see what the answer is, obviously. So the code I've provided, don't copy that. That's just making the test point. If you need to write your own, you validate it and then submit it. And of course, please put your email in and name so I know who you are and can grade your test. Put something fake in, you just won't get any results.
It's fine, we'll still find out who you are. There's no debug here.
It's up to you. I mean, you can put Joe Blogs and a fake email, but it's not going to help you. Yeah, if you don't have a compiler, wandbox.org does have one. So you write the code. I didn't get them to say how they
What is the question? I don't get the question. What is the question? How do you think you did?
Show our hands at the end.
Sorry?
Just have to show our hands at the end.
That was just statistics. That was obviously no points for that question. It was just I wanted to see how people assess themselves. Because it was good to know because everyone was pretty accurate about how they did last time.
Oh, okay. So it won't be like American Idol or something?
I'm going to add the question now. So.
How do you think you did? I did great. Well, that's not correct. You suck. Get out of here. Is that?
No, it was,
Yeah, actually, what
Simon
we'll have
Cowell.
is a little
Simon
animated Gordon Ramsay.
No, I was going to say Simon Powell. Is it Simon Powell or Cowell?
Cowell.
Yeah, Cowell. Yeah, Simon Cowell.
Crash and
They're both British, but
Well, Gordon Ramsay's Scottish.
is he?
Yeah, he doesn't sound it, but apparently yes.
When you say get the int, you mean the int in the
sorry, 1 second.
Keep looking at me. I've got nothing to do with this. This is
Okay. It's,
can't blame me for this. Well, it was sort
well, I think it's not standard. We're going to be doing these at the end of every module. Okay, it's added to the end. Hopefully, it will make you do it. Nobody's actually finished it yet.
Not joking.
You enjoy this, don't you? You secretly enjoy this.
Secretly? What do you mean secretly?
Oh, it's public.
Openly.
It's not private. Public does enjoy it.
I get to judge how well you're following.
How much is that?
Statistics screening.
No, I don't think it's sadistic. I think it's good. It's good for us to see how we're actually doing it, so keeping users engaged and learning how whether we're going too fast, too slow, so whether you can listen 2 hours. Oh, sorry, yeah, part of this. Oh, I said it should be constant correct, of course. But I wouldn't mind you. You know, you have to so that would be acceptable. Yeah, pretty sure in YouTube. For anyone who's watching on YouTube, I'm really sorry for not following. I'm busy with fixing the website. But I'm going to look at your questions now. Somebody filled in the test as me.
It's funny, wasn't it?
You get a score of 0.
That means you have to get 100%.
That's okay. He knows my email, so it was I knew it was either Justin or him. They have to know my work email.
I see.
Okay, you know my work email, but you wouldn't do that.
Thank you.
Also, because I can literally see your screen, so that kind of rules you out. 20th of September. I'll see what I can do.
Because I mean, do we want media?
I think we should get numbers of who's going to attend first, based on that. If we get enough people, I'll take the hits, I'll do it here.
Sure.
When I say the hit, I mean the organisation behind the process. But I organise stuff. When I organise stuff here, I've got to deal organise coordinate reception, talk about notices, all this shit. But we get these around. But it's only a few people, it's probably just a group of I'll do the Thursday.
I thought we were okay for Thursdays.
No. It's,
Not
I sent the list.
most of them.
By the way, guys, he didn't come to me about the complete developer podcast.
Yes, I'm fine. My answer is easy. I mean,
Yeah.
I'm always easy.
What was the question?
You pick the dates, mate. Doesn't affect me. It's going to be in the evening, so in America, right?
Yeah, it doesn't
demonstrate. So what you
Rather it was on weekends, but otherwise.
Okay, so pretty much all the Tuesdays, the Thursdays, they don't have anything until
should I actually
1st of
review
November.
your assessment?
You mean yours?
Mine.
Oh, sure. I rushed it a bit, but I'm curious. And bear in mind that I haven't attended the rest of the course, so.
You know, John, which is fine. Oh, you're right. I wrote that. That's a single line question. I'm really sorry. But you'll copy paste it.
So you can press enter. Then it's are you talking about question?
One says write a class called Privet.
Yeah, you can just press enter and you lose this. Sorry, I didn't do that.
There is a separate one. So just okay, it's not. Very good. Decent chunk, right? I mean, obviously, there's ones that you didn't fill out the code in time. You can do it again. You've got a few wrong.
Yeah.
I think it's one read tricky question. Read all the answers. I did send out the grade for the first
Just tell me whether I passed or not.
based on all this, you scored half.
These programming isn't.
So you've got a lot of the points are in doing the code challenges. So, as you all know, I was off for 2 weeks in Hungary. So I brought back some delicious Hungarian chocolates.
Amazing. You're promising the Polinica.
There's a bottle on my desk if you want to try some.
Of course not.
2% off.
I was just teasing you.
try this again.
Chandler, how would you describe zero really? It's like quark, it's no meaning of quark.
Well, it's like cottage cheese, but not
It's
fine.
not equal
Yeah,
to cheese.
that's
Yeah.
it's closer to
You're not at all what I expected.
We have this in Denmark.
What do you call
They stole it from the Danish people.
No,
Good.
I don't believe you.
Literally just
Lies.
made it, but repackaged it. So.
Lies.
People have
No.
started wars more or less, much less than that.
Yeah.
So what do you call it in Denmark?
You have it in Germany, right? Kinder, we call it Kinder.
Oh, Kinder.
Something close to Kinder.
No, Kinder's not the same.
I don't know if it's got the name. I think it's Kinder.
Ron's going to say you've got to do France as well.
Justin.
What's this in Germany? Noticing the one called Moveable.
Yeah,
Uh,
but it doesn't taste exactly the same. They've added a little bit, you know, like more salt or something.
Kinder stuff here.
no addiction.
Yeah, that's not. I think you can get that here even, I think.
You tried that?
Yeah, it's not.
Basically, just a rehash of this.
Kinder. It's only America that banned Kinder stuff, right? Kinder eggs kill children.
Is that what you were using? America, where Kinder eggs are banned to protect
You
children.
can get it, yeah. You can weigh because they are 15, but not Kinder. So yeah.
I think this test is definitely harder than the last one.
Yeah, that's the point.
In my opinion.
This is the you know, more advanced module.
Yeah, material is more advanced.
Did the answers pop up? I just submitted it now. Just pop up.
One's still coming. I
Oh,
reviewed
okay,
manually.
Cool.
Two guesses, and you'll get an email with as well.
Cool.
That'll be interesting. I will go through the answers in this session. Alright, I'm going to give you guys another 10 minutes.
Okay.
Yeah, got 3 responses in so. That's what I said.
In one place, it's not
5 responses.
in one place.
Oh, yeah, yeah. It's got to make sure it's.
No, it's oh, sorry, yes. No, it's just a normal.
What's the MacBook?
Yeah, it's not super powerful. But yes, kind of they're kind of the same colour, aren't they?
The other way to do that. Yeah, that's good.
Or go to the bathroom,
As a
just walk
flag,
out and
it's,
coming back in.
Not spark and let me know some how before you
I'll estimate 3 minutes.
Outline means
outside the body,
So you know how, when I show
because
you
of the linkage between constructors, between the right, coding the.
so out of line has nothing to do with characters. What it means by out of line is, you know how you can write function definitions either in the class, or you can just put the declaration in the class, put the definition somewhere else. When we do that, the second one is called putting it out of line. So the first one is an inline definition. So out of line means defined outside of the class. Yeah. So,
Oh, sorry. The last question, just to be clear, interface everything, not just one of the functions from the class you previously did.
Yeah, I mean this has only got one as well.
Yeah.
It's a bit restricted.
so
Yeah.
I think that it seems very silly buying a laptop and
Yeah. I mean you get. I've got a MacBook Pro, but I just sit on my desk doesn't go anywhere. This is like my portable thing. Yeah. Right. So it's kind of fine for this, but yeah, see why that's your main device has only got USB-C. It's a bit restricted.
you just have to have it everywhere.
Yeah, exactly. Yeah.
Yeah.
It's going around with you. It's annoying.
M2. We're going to go through the answers.
They have 3 minutes left. That's got bring up the quiz on.
oh, I'm logged in as an admin, so. Oh no, I can do it in a.
You click the link, it doesn't matter, it will just take you to it as if you were a user. Just click the link. Really.
It's only on one page this time. Right?
the solutions to these tests and quizzes, it would be really great if you could like have them so like at home. Because the other day I was looking at the other test and I was like, I forgot what this was.
You not see it in your report, see it.
No, it's not a solution. And especially the ones when you have to write stuff. It's not. Maybe the question with this does.
Okay. We'll see how this goes, or we can look into changing options. I'll get it fixed. Yeah, sure. It's set. I got it. Okay. It's over. Right, no responses are being accepted, so I'm afraid if you submit now, you're too late.
Seriously?
Yeah, seriously. Alright, well, who needs to submit still? Alright, I'll give you one more. Wait for it. Okay, yeah, you've got, I'll give you another 60 seconds. So I can cut it slightly before.
Some questions still in retention. Is the question out
The only mandatory ones are the ones that aren't actually challenged. They're just queries. Twenty seconds. Everyone submitted? Yeah, that's your countdown, that's literally.
Oh, not dumb. She'd be shouting at them like Gordon Ramsay now.
That's all right. I last two questions. I didn't stop.
2, 1, close. Okay, so let's go through this. So it seems that most of you got your names right, so that's a good start. So obviously for the first one, objects are modelled as a class or struct type and used for creating instances of them. Hopefully that's fairly obvious. So then we had member visibility and inheritance of class defaults to private and struct defaults to public. Of course. So that was correct. The correct one.
Once or twice.
Yeah. Okay, so let's go through these. The private keyword signifies that things are not accessible outside of the class itself. Well, I mean that's what private means, right? So you should be able to get that. The protected keyword signifies that things are not accessible to derived classes. Well, no, that's not what it means at all. Public keyword signifies everything is accessible to everything. Protected keyword says that it's only accessible to itself and derived. Yes, of course, that's the correct one. If a class declares a friend, then the friend can only access protected and public things. No, that's not true. If it declares a friend, the friend can access everything. The class can also access everything in the friend. No, that's not true. It doesn't just magically get access to the other guy. If it declares a friend, then the friend can access all of its stuff, but it doesn't just work the other way. So that's the correct one.
Friendship is not symmetric. You can be friends with somebody and they're not friends with
You can't just break into their private stuff by saying, "Oh, you're my friend now." So obviously for this one, we need to write a class called class privint. So priv int, and we're going to save some space. So we're just going to say int public, and then we'll just do int get, and that will be const accessible. And it will just return There's obviously several ways. It doesn't matter what name you give it. I will grade you correctly as long as you've satisfied the requirements. This is not quite right, but I'll fix it in a sec. So one of the key things I do want to see, which I haven't done. Actually, no, never mind. Sorry, I'm thinking of the question at the end. So this is fine. That's acceptable. The semicolon I won't ding you for too badly. But that's got a getter. It's const correct. It's got a setter. Cool.
What do you need to return?
Yeah, that's what I was thinking. Well, that's not what I did. But
Hold on. Yeah, that's completely wrong. Right, that's what I was expecting. Oh yeah, sorry.
the other one.
Don't worry. I can actually read and write C++. As it happens, I'm just standing here and yeah, completely screwing up. Anyway, so
Same like with the website you did.
I think you want to be careful.
wait, was I cloned and made several years older, and that's actually the result?
By the way,
Um,
it wasn't me.
Yeah, I'm Tom. In 30 years. No, I'm kidding. Okay, so we had the structure interface, which declares a pure virtual do something. Then there's an inheriting derived, which has the nice override check, of course. And then we declare an instance, and then we do this completely invalid thing where we have a by value construction of interface from derived, which is obviously not going to work at all. It's going to fail to compile. If this was a reference, it would obviously work, or if it was a pointer and we took the address of, that would work, but this will not. So it will fail to compile, and then for your bonus points, obviously you would write something along the line. Go on.
That's what I thought. Won't you get slicing?
No, there's no
Well,
slicing.
you
It's pure virtual, so it just won't construct.
You would have got slicing, except that virtual in the struct interface, that's a pure virtual function. So equals naught is pure virtual. So interface is an
It won't
abstract
even
class,
construct.
so you can't create.
We should get quarter
You
points.
would have if it was actually not pure virtual.
Otherwise, you would have got slicing. So that's a good observation.
So you're correct, except not. You're correct if it wasn't actually that code. So obviously the answer here would just be if you write something like
Well, we get like 1 point, like maybe 1 point there, half point there.
sorry.
Like a
You
half
want
point.
a half point for picking up the slicing problem.
Yeah, that's what I was like.
You get 2 points. You get 2 points for just saying this cannot work. It does not compile. It cannot construct. If you put something else in, because that's where I was trying to catch you out, which was that you need to realise it doesn't even construct. There's no slicing. It does not construct. So if you said, oh, it slices and doesn't work, then that's not true. It doesn't slice. There's nothing. No, it doesn't compile. Anyway, so that's that one. Okay, then we've got all the correct options. So virtual keyword cannot obviously be applied to functions and fields. It only works on functions. It does, of course, allow for a function to be over in a derived class. The override keyword is not used to override a virtual function declared in a base class. If your signature matches, it overrides anyway. However, it is a compile time safety check. So, absolutely.
I meant to change the wording of number 3. Say the override keyword must be used to override a virtual function.
That was deliberate. A class containing all pure virtual functions cannot be directly instantiated, of course. That's not true, but that was hinting at something there. It is not always illegal to call a pure virtual function in a base from a derived class. If there's a definition on the pure virtual, it will work just fine. It's a perfectly valid method to have a pure virtual in a base that does have an implementation, a definition, and then you allow derived classes to call it. That is well-formed C++. And the final one is valid to call pure virtual function base from derived class if a definition is provided. That is what I just said. Okay, so we consider the following code. We have a pure virtual RNG. Again, we got derived, reference interface, and of course we just return the value. And then the question here is what's going to happen. So it will compile. It will not compile and run correctly, sadly. There is a bug. And who wants to say what the bug is?
Does it have anything to do with the fact that you called new and didn't call like delete afterwards? No?
It's in a unique pointer, so unique pointer will call delete. The problem is that unique pointer will call delete on interface, and interface does not have a virtual destructor. So it calls the destructor of interface, which then does not dispatch to the destructor of derived, and we end up leaking 1 byte. We leak char.
That's not
Whenever a class has any virtual functions, give it a virtual display.
About 5 minutes. So then I'll answer why it's correct. So you just say no virtual destructor, and if you want to be really fancy, you could say X is leaked. But okay, so subject object are true. A class can be marked as final, prevents any further inheritance. Yep. That's obviously contradicting, so it can't be right. All member functions can be marked as final to prevent further overriding. No, because if it's just a standalone member function, that's not going from virtual. This one is the accurate one, which says that it must be virtual, which is a bit silly if you declare a virtual and then mark it as final, but you can do it. Or overriding a virtual, and then obviously it prevents anyone else from overriding further. It is possible to name an L value, a variable, final, for example, int final equals 0. Yes, this is actually very legal, because final is a contextual keyword. The same thing applies to override. You can call a one override. Don't do it. It's really stupid, but you can do it. And obviously that's contradicting. It's wrong. Okay, so we say create an interface class for our INT. So what we're going to do here is we're just going to scroll up to where we implemented our privint. So I'm going to copy this right now. And then we're going to go back down. And where is it asking me? Here we go. So we'll just paste this bad boy in here. And let's make our interface. So I'm going to be lazy and just do a struct. So struct, what was it called? INT. And we'll have our virtual int get const equals 0. Our virtual void set int equals 0. And then, of course, what I would expect to see is our virtual tilde. Okay, where's tilde? There's tilde. INT. Oh, sorry, it's INT. Equals default. And then, of course, the final touches are INT. Override, and of course and that was it. So all of your submissions are obviously in now. They'll be graded. Hopefully I'll be as fast as I was last time and get them in within a day or two. You'll get an email when I've done it. And next week I'll see how well you predicted how well you did, and go through the statistics that it collects. Cheers.
Right, thank you. So that's it. We're done. Next time.
Start over.
Next time. Yes. I'm going to call it Initial C++. Tell your friends, tell your enemies, tell your neighbours, tell everybody. If they're interested in learning C++, come along. Last time we started the course, we had a fantastic response. We had like 300 people sign up. If we can get a lot of people this time, that'd be awesome. So please do spread the word. And in the meantime, come for a drink in the pub. All right, thanks everybody.